My name is Jesse Furman, and this is an instructional video for Anthropology 200 online at OSU. And this video will explain to you how to construct a cladogram based on the data that you will be given in your online homework. A cladogram is a visual representation of the relationships between a group of organisms. And the type of relationships I mean are ancestor-descendant relationships. Okay? So there are two main principles that we're going to need to cover here today in order for you to construct a cladogram properly. The first one is the difference between primitive and derived traits. The second is a sort of well-known principle known as Occam's razor. Now, the first principle, primitive and derived traits. Primitive traits are traits that are more ancient and original to the lineage. So, for example, in mammals, the first mammals had 5 digits on the ends of their limbs, much like we have. Okay, but most mammals today actually have 4, 3, 2, or even 1 digit on the end of their limbs. So having 4, 3, 2, or 1 digits at the end of the limb is a derived trait. It evolved later. Now, the second principle, that of Occam's razor, which basically states that all things being equal, okay, the simplest solution or explanation is going to be is more likely to be correct. Okay? So with reference to a cladogram, okay, that means that the solution or the cladogram that we're going to construct needs to be the simplest one, or the one that has the least complications in it. So that's going to entail two things. The first is that we're going to try and construct it such that each trait evolves as few times as possible. Okay? And second, we're going to make sure that that we have as few switching back and forth from a primitive to a derived state of a given character. Okay, so it's unlikely that, for example, that humans with 5 digits evolved from something that had fewer digits, because the ancestral mammals had 5 digits. We have 5 digits. There's probably a path that connects us through a whole bunch of other organisms that all had 5 digits, as it's the primitive trait. All right? So let's use the example that's given in your book, in your lab manual, and we will try and construct one here using this data. So as you can see, we've got 5 organisms, and we're going to look at only 4 traits. Now, I believe the actual problem that you do in your books, and that's in your homework online, has a fair bit more than that, maybe as many as 8, I'm not sure. But the basic idea will be the same, all right? So, as we can see here, there's, oh, and the other thing to keep in mind, of course, is that the lowercase letters represent the primitive version of trait. Okay, so number of digits is our trait, then that's going to be represented by then the primitive state, 5, is going to be represented by the lowercase, whereas something else, another state of it, would be represented by an uppercase. All right? So, as number 1, organism number 1 has all primitive traits here, and none of the others do, that's the place where we're going to start. All right? So, at the base of our cladogram, we're going to put organism number 1. Okay? Now, the next one, number 2, where are we going to place this? Well, organism number 2 has a derived version of trait A. But if you look down the rest of them, none of the others do. So it's unlikely that it's going to be on the same evolutionary path or in the same lineage as the rest of these. So we're going to put another little branch off this way, from 1 to number 2. Now, I've got 3, 4, and 5 left. Okay, so just sort of check these off here. Now organism 3 has also only one derived trait. Trait B is derived. Now 4 and 5 also have a derived form of trait B, but they have other traits too. So how are we going to put this in a cladogram here that keeps this with only one evolution of trait B? Well, we'll do this. We'll do 1 going off to 3, and then 4 and 5 are going to come off of 3. That way, this derived form of trait B only evolves one time, right? This change from 1, where it's lowercase, to 3, uppercase, all right? Now, 4 and 5 here have different derived traits aside from B, right? 4 has a derived form of trait C, and 5 has a derived form of trait D, right? So from here, they're going to have to be separate. So we'll put 4 here, 5 here, and there we have it. That's our cladogram. Now obviously yours is going to be a little bit more complicated because you've got, I think, all the way up through, I'm looking right here, H. So A, B, C, D, E, F, G, H. So 8 traits. So there's twice as many as here. But the basic format and the basic way of going about constructing this is going to be pretty much the same. Good luck.